We've been asked in class to sketch the isotherms of a perfect gas at a constant temperature, so isotherm, on a set of pressure versus volume axes. And we want to be able to indicate which function is at which temperature. So we considered this to be a compression process. That was the easiest way for us to think about it, I think, as happening as a physical event. So let's start here. So we have a gas at a constant temperature T1, and we want to reduce its volume. So we are compressing it. I know we normally move from left to right, but in terms of the experiment itself that we might do to generate this data, it might be easier to think this way, and also to predict the shape. So we're going to increase a little bit, and then at a certain point we become a very steep straight line. Think about it physically. Once you reduce the volume to a certain point, it's going to be very difficult to do that even more, and so the pressure is going to go up. Now, where's our starting point for T2? And let's say that T2 is greater than T1. So now I have a higher temperature. A new experiment, I'm going to plot on the same set of axes, and I have the same number of moles of gas in the same initial container. So clearly, if I am going to start at a higher temperature, the pressure is going to be higher. So I'm going to start T2 about here, and it's going to end up being nested inside like this. And then finally T3. So there's my T2, that's my T1, and here's my T3. Okay, so what the book shows, the book adds a label on top like this and does increasing temperature. And that's one way you can indicate the increasing temperature on the isotherms. All right,